Welcome to Brain Vision.
Now we're given the scenario where two masses, one heavier than the other, are being hung over a frictionless pulley, and the heavier one starts to move down. Right? And this will mean that the lighter one moves up, right? So we're given that it moves down by a distance of 1.2 meters before reaching a velocity of 3 meters per second. And we're also given that the masses add together to give a total mass of 15 kg. I'm going to try to solve this by looking at the energy. So total energy at the start versus total energy at the end. Right. So total energy at the start we're going to assume is 0 when they are not moving, and we're going to assume that the gravitational potential energy is 0. But at the end, the gravitational potential energy for MB has decreased, right, has dropped by mp times d times g, right, mgh. So mgd, this is the amount that the block has lost, and it is actually converted into the kinetic energy of both of the blocks. So that's half times ma plus mb times v square, right? They are traveling in the same speed because they're connected by the same string, and it is also converted into potential energy for our mass A because it moves upwards, right? So this ma times g times d. So this is our energy equation. We put in the values that we know. So this is 15 kilograms, and we know that our velocity is 3. We bring this expression to the left hand side. So this mb minus ma times g times d is equals to half times 15 times 3 square. We can then find an expression for mb minus ma by dividing g times d over. This leaves us with 5.734 kg. And now we can basically find the masses by using these two equations, right? Equation 1, equation 2. We add them together, 1 plus 2, to get 2 times the mass of mb. And so mass of the heavier block would be 10.4 kilograms, and mass of the lighter block is just 4.6 kilograms.